Alright Circuit City friends, today Rick the resistor and Tron the transistor are teaching us something super important, how engineers agree on direction and signs so that circuits talk the same language. Once you know these rules, you'll never get confused about plus and minus again. Let's start with the direction of current. Here's a fun fact, when we draw a circuit, we don't actually know for sure which way the current is really flowing, so we just make a guess. We call this our reference direction. We usually assume current flows from the higher potential, marked plus, to the lower potential, marked minus. Now here's the cool part, if we do the math and get a positive answer, our guess was right, the current really does flow that way. But if we get a negative answer, no problem, it just means the current is actually flowing the opposite way. So guessing wrong isn't really wrong at all, the math always tells us the truth. Next, let's talk about the sign rule for KCL, our junction rule. This course follows one simple pattern, current leaving a junction is called positive, and current entering a junction is called negative. So outgoing is a plus, incoming is a minus. Watch, if 2 amps and 3 amps are leaving a junction, that's 5 amps outgoing, and if 4 amps are entering, that's 4 amps incoming. Outgoing minus incoming, 5 minus 4 equals 1. That's how we know the numbers balance out. Now for the big one. The sign convention for KVL, our loop rule. Here's the trick, first, you pick a direction to walk around your loop, clockwise or counterclockwise, and once you pick it, you stick with it the whole way around, just like walking around a racetrack in one direction. As you walk past a resistor in the same direction as the current, the voltage drops, so we write that as negative. But when you walk past a battery from its minus side to its plus side, the voltage rises, so we write that as positive. So here's how you actually apply KVL, step by step, like a checklist. First, choose your loop direction. Second, start anywhere and travel all the way around. Third, write down the voltage change for every single part you pass. Resistors get a minus sign, batteries crossed minus to plus get a plus sign. Fourth, add up every single voltage change you wrote down, and for any complete loop, they must all add up to exactly 0. So remember, team, current direction is just our best guess. Higher to lower. At a junction, outgoing is plus and incoming is minus. And around a loop, you pick one direction and follow the resistor rule and the battery rule the whole way through. Same convention, same rules, every single time, that's how engineers think, and now that's how you think too.